Hi everyone, I'm sorry I'm not here today. I'm still a little sick. Here are your notes for class today. I appreciate you all watching these and being nice to Miss Hardy. Today is 10/22/2019. We're actually going to talk about this thing called inverses. So recall a definition of a function is a relation in which every input has exactly one output. A relation is a function that passes the vertical line test. Remember, this passes the vertical line test, so that means it's a function. If we switch the inputs and the outputs of relation, this new relation is called its inverse, and that's what this chapter is all about. You may see me write it with f -1 f of x. That's like the universal symbol, or you might see g inverse, and that like -1 means inverse. A new relation may or may not be a function. For example, y equals x cubed and y equals the cube root of x are examples of inverse functions. So the cool part about inverse functions is essentially all we're doing is taking all the x's and move them to the new y spots. So this is -2, -1, 0, 1, 2. And then you take all of the y's and where do we put them? You guessed it, in the x spots. So this is 4, 2, 0, -2, 4. So all you do is just switch the x's and the y's. The graph of its inverse relation is a reflection of its original relation over the line y equals x. So this right here is always the line y equals x. Slope of 1, it's like y equals 1 over 1 x plus 0. So how to find the inverse? Today you write the original relation, which is like y equals blah blah blah. I'll say 2x plus 5. And then second step, you switch the x and the y. So now you do x equals 2y plus 5. So you see how you switch? That's called variable interchange. You will hear me say variable interchange a lot this chapter. And after that, you're going to solve for the new y. So you're getting y minus 5 all over 2 equals x minus 5 over 2 equals y. And we're actually going to practice solving that today. So to verify function inverses, to see if they're inverses, they cancel each other out. So the composite of a function inverse should result in one alone. But we're not really going to worry about that today. Or we're going to talk much about composite functions, so don't worry about that. Alright, so to find the inverse. First thing is we switch x and y, so that x equals 2y minus 4. You see how I switch the y and the x? 1 point for just doing that. Now I'm going to add 4 to both sides. X plus 4 equals 2y divided by deuce. Y equals x plus 4 over 2. Or you may see f inverse of x equals x plus 4 over 2. I like to use f inverse of x, then I know which one's the original, which one's the inverse. So we're going to practice these ones. So first thing, this right here is just y. That's y equals 3x minus 6. So we can switch it. So x equals 3y minus 6. Essentially, you just gotta get really good at doing it. Right here, y equals x cubed minus 5. What's that first step? Nice job. Variable interchange. X equals y cubed minus 5. Add 5 to both sides. X plus 5 equals y cubed. Now it's opposite of cube. Nice job, cube root. So y equals the cube root of x plus 5. Or f inverse of x equals the cube root of x plus 5. This one. Switching. X equals 2 y plus 3 cubed divided by 2. X over 2 equals y plus 3 cube root. So x over 2 cubed equals x plus 3 minus 3. Y equals the cube of x cube root of x over 2 minus 3. This one, switch them. X equals 10, y minus 40 over 3. I'm going to times both sides by 3. 3x equals 10, y minus 40. I'm going to divide by 10. So 3x over 10 equals y minus 40. You guessed it, at 40. F inverse of x equals 3x over 10 minus 40 plus 40. Some helpful things is, I think when you solve, you use PEMDAS, but when you do inverses, you do them backwards. So remember, subtraction, addition, multiply, parentheses. So then you kind of do it in order. Alright, some more notes today. You'll guess my number. Okay, your teacher will think of a number and tell you some information about that number. You will try to determine your teacher's number. You can use a calculator or paper. It helps when you think you know the number. Sit silent, don't tell anyone. Be sure to give others a chance to figure it out. Okay, Mr. Ahlers has his number. Some questions. If I add 4 and multiply by 5, I get 100. Anyone have it? So the equation would be x plus 4 times 5 equals 100. So you divide by 5, and you get x plus 4 equals 20. Subtract 4, you get x equals 16. That's my number. Good job, everyone. I manage function below. She puts in a 3 into the machine, 7 comes out. So I would say f, the notation is f of 3 equals 7. When she puts in a 4, a 9 comes out. So f of 4 equals 9. When she puts in a negative 3, a negative 5. So f of negative 3 equals negative 5. So I'll make a table. Because I have less space, can I make a narrow table? Any ideas what happens? think it's times in by 2, and then multiply by 2, and then add 1. Everyone's function may suddenly start working backwards. It begins pulling outputs back up into the machine, reverse the machine, and turn the output. If 7 is pulled back into the machine, what a value then can come up top. So if you put 7 in, you get the original input. So essentially what they're asking for is f inverse of 7, which equals 3. Working backwards because you take this value and you get the original, which is 3. And that sets up a new backwards function machine enters in the other inputs. When you find f inverse of 9, what do you get? And f inverse of 5, negative 5, what do you get? Remember, you look at the original values. And this should be negative 3. So looking at these ones, what are the original? What do you get when you put in originally? Nice job. You get 4 and negative 3. Record the inputs and the outputs of the backwards function machine in the table. Record the numbers beginning pulled back as an x. The numbers are coming as y. Explain in other words what Henman's backwards function is doing. It is indirectly taking the inverse. When you're facing the original function, terms was y or f of x equals 2x plus 1. And the backwards machine, gotta switch it. X equals 2y plus 1. So x minus 1 equals 2y divided by 2. F inverse of x equals x minus 1 over 2. How two functions relate? If you plug in the original value, you get the output. If you plug in the output into the inverse, you get the input. The function machine at right is there. If the crank is turned backwards, the number should be pulled up into the machine to have 4 come out. So I think that one you just want f of 4. Find out 5 times 4 plus 2 equals 22. So if you put in 22 into the machine, what should we get? Goal wants to build a new machine that will undo f of x tested input. What must Cole machine do to 17 to undo it to return the value of 3? Subtract 2, you get 15, and then divide by 3, you get divide by 5, you get 3. The undo function is called an inverse function in notation with this f inverse 1. Note that the negative 1 is not a negative exponent, it is a mathematical exponent that indicates the inverse of f. Let's write the equation. So f inverse of x, we're taking the backwards of that, so right here. So it's going to be x minus 2 over 5. X minus 2 over 5. Choose the value of x. What strategy can you use to show that the equation f of x undoes the effect of the original function? So if I take f of 4, I got 22. F inverse of 22,